Clear, guys? Okay, done. So let's start the session. So in the last class, we are discussing about the encoding. And in the encoding, I have discussed about the ordinal data. For ordinal data, ordinal encoding. For nominal data, nominal encoding. We are going to do, right? Next, once let us see with for nominal data, how we are going to encode the nominal data. So here we are having a nominal data that is called as Chennai, Bangalore, and Hyderabad. These are the unique values. So if you check with these are the, what are the unique values means Chennai, Hyderabad, and Bangalore. And for this, what we have to do is one hot encoding. One hot encoding is also called as dummy encoding. Dummy encoding is also called as nominal encoding. Everything are same. Nominal encoding or one hot encoding or dummy encoding. Everything are same, where finally we are going to encode the nominal variable, right? Now here, what I'm going to do is I'm going to do the pd.data frame of first sklearn.preprocessor import one hot encoder. I'm going to import the one hot encoder. From the one hot encoder, what I'm going to do is I'm going to write one hot encoder drop is equal to first. Now what is meant by drop first means first column will be dropped. Means in this case, if you check this one, this is Chennai, Hyderabad, Bangalore. The first one, it is going to consider the Bangalore, followed by Chennai, followed by Hyderabad. It is going to take like this. Out of which the Chennai is 1 and remaining 2 are 0. Bangalore is 1 and remaining 2 are 0. Hyderabad is 1 and remaining 2 of them are 0. So it is going to consider in this way. Now for this, it is going to remove the drop first is equal to true, means one of the variable I'm going to drop. Out of 3 categories, one of them I'm going to drop. In the last class, I have told you, if n categories are there, if you are having n categories, we are going to encode with n-1 columns. We are going to create n-1 columns. N categories, we are going to convert to n-1 columns. So here, what I am having that Chennai and Hyderabad, that I am going to encode to n-1 columns, right? So the same thing will happen. One hot encoder drop is equal to first. Drop is equal to first means first variable will be dropped. Out of all of them, first one will be dropped. You can drop anything. You can even drop the Chennai. You can even drop the Hyderabad as per your choice. You can drop anything. So here I'm dropping the drop is equal to first. First one means first one will be dropped. Now after dropping here, just observe this one. ENC dot, what I have told you yesterday. For anything, first we have to do import the from sklearn dot pre-processing, import one hot encoder. After that, one hot encoder drop is equal to first. Generally, if you are working on a sklearn, what is the steps? First one is import. Import from sklearn, you are going to import whatever the function you want. You are importing this one. And this function, you are going to save in a variable name. As per your choice, some variable name. And whatever the variable name you are using, the variable fit underscore transform. These are the 3 steps. Every time these are the 3 steps, right? We have discussed. One is import, second one is save the function, and third one is fit and transform. So whenever you are using the from sklearn.preprocessing, the syntax is from sklearn.preprocessing. You are going to import whatever the function you want. You are going to import the function, some function. Whether it is a one hot encoder, whether it is a simple imputer, whether it is a ordinal encoder, or whether it is a label encoder, whatever it is, just you are going to import the function. As per your requirement, you are going to import. Now, once you have imported, next second line. In this function, you are going to save to a variable. Whether it is a simple imputer, you are going to save to a variable. Whether it is a outliers, you are going to save to a variable. Whether it is a Winchester technique, you are going to save to a variable. Whether it is a label encoder, you are going to save to a variable. Anything, you are going to save some variable name of your choice. And this variable dot fit underscore transform. You are going to do the fit underscore transform. And inside that transform, if this function, each function will be different type. This function will have either series. If the function is having series means you have to give series, or data frame means data frame. If it is series means you have to use, if it is series means you have to use df of a single column name. Directly you have to write like this. If it is a series. If it is a series, just you have to write like this. If it is a data frame, you have to write double square bracket and column name. You have to use like this. So now whether inside that, whether data frame is there or series is there, that is depends upon the different functions. Every function will not be the same. Every function will not be the same. So now if you observe here, in the last class, whatever the label encoder we have taken, see, from sklearn.preprocessing import label encoder. And this label encoder you are storing to a variable LE, and LE.fit_transform of the inside whichever the variable you want to convert, you are writing that particular variable. So here for this one, we have to give an input as series. The input is series. So that is the reason I'm going to use the one single square bracket. Now, for example, if you go with the ordinal encoder, again from sklearn import the ordinal encoder, and you are going to save this ordinal encoder in a variable name, and that variable name fit and transform input, where this particular function has to be given as the input as data frame. So you are giving as a data frame as the input. So double square bracket we are going to use. Now coming to the this one hot encoder. Now the same to same. First one is I have imported. Second one I have saved into a variable name. Third step, I'm going to write whatever the variable is there, the variable fit_transform of the, inside that I'm writing the series. Up to here it is common. Okay. Now if you write from here to here, if you write from here to here, and if you start executing only this particular thing from here to here, if you start execute, and if you see, okay, let me execute this too also. If I execute like this, now in the last line, it is getting executed. The last line is getting executed, but it is going to give some kind of matrix format. I don't want matrix format. So what I'm going to do is to array. Only one hot encoder function will give the output as function, but remaining everything will give output as the data frame. But one hot encoder function will give the output as a matrix. So where we have to convert to an array, to array, to array. So now you can see here 1 0 0 0 1 0. Is that clear? Now this array, if you want to convert this array to a data frame, what we are going to use? pd.data frame. I'm going to write pd.data frame. Now if I write the data frame, now I'm going to get a data frame like this. Now as I've told you earlier, what is this? First one is Bangalore, Chennai, Hyderabad, where Chennai is 1, remaining is 0, Bangalore is 1, remaining 0, Hyderabad is 1 and remaining 0, out of which the first one you are dropping. Now first one if you drop, now Chennai is 1 0, Bangalore is 0 0, Hyderabad is 0 1. Can you see the same answer here? That is 1 0 0 0 0 and 1. Everything is same. But here if you observe the names of these column names are 0 and 1. I don't want the column names like that. What is the column names I want? Miss, what are the column names you want? Columns. You write the column names. Columns is equal to, what are the names, miss? First one. What is the first one? It is Chennai. So write the first one is Chennai. Write the second one is Hyderabad. HYD. Now if you start execute, now you'll get the Chennai and Hyderabad. Is that clear? So this particular function, one hot encoder function, will give the output as the matrix. So that is the reason I'm going to convert to an array. Okay. And after converting to an array, I'm converting to a data frame. Is that clear, guys? Now, if you observe this one, your original data set. Now, what is this encoded data set? This is the encoded data set. Now I'm printing my encoded data set. Just see this enc_df. Now this is the encoded data set. This encoded data set should be attached to the original data set. So what I'm going to do to how to attach to the original data set? This is the normal one. So this one has to be attached to means what I'm going to do? I'm going to write concat. pd.concat, the original data frame and this one. These both of them I'm going to concat. Now you can see the concatenation. Is that clear? So Chennai was converted as 10, Bangalore was converted as 00, Hyderabad was converted as 0 and 1. Clear, guys? Now, this is one option, option number 1. Now we are having one more option that is called as dummy encoding by using the pandas. So what I'm going to do is pd.getDummies. I'm going to take pd.getDummies, df of town. Df of town means what is df? This is the df. This is the original data frame. Okay. This original data frame I'm going to take. For this original data frame, I'm going to have with respect to df of town column and drop first is equal to true. Drop first is equal to true means first column will be dropped. And I'm going to get like this directly. In one shot, I will get directly. I don't need to convert to array to data frame like this because it is already a data frame. Pandas now. pd.getDummies means by default it is pandas. So what you have to do? This one also you have to store in the encoded df, and after that you have to concat. If you want, you can concat enc_df. Right? So similarly, how we have concated here, in the same manner, we can concat this one also. Right? Clear, guys? So that is one hot encoding. Drop first parameter. What is drop first parameter? Means first column will be dropped. I told you yesterday, dummy variable trap. In the dummy variable trap, we are going to convert n categories to n-1 columns. We should not convert to n columns. So we have to drop one of them. Anything of your choice. Anything you can choose. Directly they have given within that function itself, drop first option is there. By writing the true, it will drop the first one. Right? Is that clear? Sir, when we are dropping first column, but Chennai is the first, how Chennai will be the first? Alphabetical order. It is going to take alphabetical order. Bangalore, Chennai, and Hyderabad. It was going to create with respect to first one is Bangalore, followed by Chennai, and followed by Hyderabad. It is going to create in the alphabetical order. Done? So that is encoding. So once again, let's have a small recap. Whatever the data pre-processing techniques we have done, just write in the notes, different data pre-processing techniques. Different data pre-processing techniques. Out of which the first one is data cleaning. The first one is called as data cleaning. And the second one is called as data wrangling. Okay. First one is called as data cleaning, followed by data wrangling. Just give me a minute. I'm opening a new notepad. So data pre-processing. Now, first, let's start with the first one. First, what is meant by data pre-processing? Let's start with initially what is meant by data pre-processing. What is data pre-processing, guys? Data pre-processing means you're processing the data before to the machine learning, before sharing to the machine to learn. Whatever the things you are going to do before to sharing to the machine to learn, that is called as data pre-processing. Means simply to understand, we are going to learn the data science, machine learning, and artificial intelligence. These concepts we are going to learn. To learn these concepts, first we have to cover the Python. Without covering the Python, directly if you open the machine learning with Python, on the day one itself, if I open the machine learning with Python, there if I say that this is called as a data frame, this will load as an Excel sheet, means temporary purpose. That example only you will understand. You will not understand what is meant by data frame, what is meant by series, what is the difference between these two, and a data frame can be created in how many ways. You don't know anything. Without any prerequisites, directly if I open the machine learning with Python, what happens? So for that, what we are going to do, in order to understand the machine learning with Python or data science with Python, first we are covering the prerequisites. What are the prerequisites of this one? Means first we have to cover the Python. What is, once we cover the Python, second one is we have to cover the statistics. If one is very good at Python and statistics, then those people can start the data science course actually. Actually, for data science course, that is the prerequisites. For any data science course, that is the prerequisites. But here, for this course, we are not having any prerequisites. What is the reason? Because we are only starting from the scratch level. We are only starting from the initial level, that is from the core Python, followed by NumPy, followed by Pandas, all these things. I have explained you the initially the core Python. In the core Python, I have explained you, I have spent almost 1 month. 1 month we have spent on the Python only. And in next 1 month, we have spent on the statistics and all these things. Almost your course was completed 2 months, nearly 2 months, right? Now, if you observe this 2 months duration, we have completed 1 month for Python and 1 month we have spent on the statistics and data pre-processing or EDA, whatever the things. Now, in these 2 months, whatever the things we have done, that is the basics of the entire machine learning and artificial intelligence. Now, initially, I have explained you what is meant by strings and what is meant by input function, how to take the input function from the user and how to execute this one for loops and how to execute the while loops. All these things we have discussed so much detail in the core Python. We have spent the time on the core Python. Why I have spent the time? Because that is not useful now, basically. But still we have spent so much of time. Why? There, if you understand the fundamentals, now the next in the wherever the data frame is there, now I'm working on the data frame. What is meant by data frame? Automatically in the backend for loop it is executing. For loop it is executing for each and every value it is applying that concept. So for data frames are created based on the for loops. Okay. So for everything, if I go with the pandas, what is the base miss? NumPy. For NumPy, what is the base miss? For loop. For loop, what is the base miss? If list and operators, whatever the operators or range function, whatever we are having, that is the base. Like this, we have covered from the base level completely. So this is called as data pre-processing. Data pre-processing means before entering into the high level, completing the basic one. Means now, once we do the data pre-processing, now the machine will start learning. Whatever the data we share, now the machine will understand. Because we are going to do the scaling. Once we do the scaling, everything will be on the same magnitude. We are going to do the transformation instead of skewness to normal distribution. Now the data will be almost similar to whatever the algorithm it has designed. So all these things are whatever the data pre-processing. What is meant by simply data pre-processing? If anyone asks me, preparing the data, preparing whatever the data, preparing the data in such a way, the machine will understand. The machine will understand, will learn. The machine will learn and predict with maximum accuracy. Okay, you are preparing the data in such a way the machine will learn the data, and predict the answers with maximum accuracy. Will learn the data and predict with maximum accuracy is called as data pre-processing. Okay, this data pre-processing is also called as, this is also called as data preparation. This is also called as data preparation. Data pre-processing is also called as data preparation. Both are same. Data pre-processing or data preparation. Right? The first one is preparing the data in such a way the machine will learn the data and predict with maximum accuracy. The machine will understand. First, it will understand. If you give the missing values, it will not even understand. If you give the text data, it will not even understand. It will not even understand. Learning secondary. First, it has to understand now. To learn means first it has to understand. After understanding, learning will start. Without understanding, from where it will learn. Right? So, this is called as data pre-processing. Within the data pre-processing, we are having multiple. One is called as data cleaning. One is called as data cleaning. Two is called as data wrangling. Data wrangling. And three is called as dimension reduction. Dimension reduction. The third one is called as dimension reduction. Okay. So whereas majorly to say, we are having basically two things. One is called as future engineering. Heading is future engineering. Okay. And the second one is called as future selection. Future engineering and future selection. These are the two concepts. Okay. Now, data wrangling and data cleaning, whatever we have discussed from last 3 days. Okay, from last 3-4 days, whatever we are discussing, including the treating the wrong data, treating the missing values, or treating the outliers, all these things, data cleaning and data wrangling process. This both of them is combination is called as future engineering. Okay. What is meant by future engineering? Means engineering the future. Engineering the future. Generally, students will say the answer like this, right? What is meant by future engineering means future engineering future, right? So what is meant by engineering the future? Meaning of that means rectifying the future. Rectifying the future. Rectifying or modifying. Rectifying or modifying the future. What is meant by future? Future means nothing but variable. Both are same. Future. Okay. In the notes you can write separately. Future. Variable. Column. Three of them are same. Future is called as in machine learning. In ML, it is called as future. In variable, in statistics, it is called as variable. Each column is called as variable. In general usage, it is called as column. This is general usage. Whatever we generally use, column, sir, column name, column, and like this we use. This is our general usage. But in the statistics, the column is also called as variable. The same thing in machine learning, it is called as future. Everything are same. Means simply to say, sir, here you are having the three columns are there. Na? Town is according to us, it is a column name. For machine learning, it is the future name. And this particular future, you are going to do engineering. In engineering in that such a way that you are rectifying the data. You are rectifying or modifying the data. You are rectifying or modifying. You are converting. You are modifying the data. If it is data cleaning means you are rectifying. In the data wrangling, you are modifying. So data cleaning and data wrangling, both combination is called as future engineering. Future engineering means rectifying or modifying the future is called as future engineering. Now within the data cleaning, we are having the different options. What are the different options? One, dealing the wrong data. You have seen already how to work on the wrong data. This is the first one. Okay. Wrong data. If there is a wrong data, what we have to do? We have to replace with the correct data. Next, we are having the second one called as wrong data type. Then what we have to do? We have to modify to the correct data type. Okay. Next, we are having in terms of duplicates. What we have to do for duplicates? We have to remove the duplicates. The solution for this one is remove the duplicates. Next, we are having in terms of fourth one is called as missing values. What we have to do for the missing values? Either we have to remove or we have to replace. While replacing, we have to replace statistically either with mean, median or mode. And next one is fifth one. And which is the fifth one is outliers. You have to treat the outliers. Now, what is the outliers? Outliers means which are distant from data point. And what is the solution for treating the outliers means? Either we have to remove or we have to replace or we have to retrain. What is meant by retrain? The third one. What is meant by retrain means we have to keep that and we have to analyze. Means what is the meaning of that? For example, I am working on the Flipkart sales. In a normal month, every month, in the May month or June month or July month, the sales will be normal. But in the October month, whenever the Big Billion Day sales will be there, in the October month, very huge amount of sales will be there. Now, when I see that huge amount of sales, and if I compare with the overall yearly data, I have taken the yearly data from January to December. In the month of in the month of October, the sales will be very high in India. In the US, in terms of December will be very high. For them, the December will be very high. For India, October month will be very high. So now if you observe the entire data, if you take the entire data, whatever I'm having, if you consider the entire data, in that the October month sales will be very high. Now what I have to do with that October data? I have to replace a no, because that is a genuine. Really that much of sales was happened. Now next, either are we going to remove? No, that one also we are not going to remove. We are not neither remove, we neither replace. We have to retrain that and we have to analyze. And the reason behind that is very big festival is there, which is a lengthy festival of 9 to 10 days festival. Dasra festival is 9 to 10 days festival. Every festival is of 1 day or 2 days, means only Dasra festival is of 10 days festival. So that is a different festival. So that is the reason we are having that one. And we have to analyze in that way. And if someone asks, predict the Flipkart sales, for example, tomorrow, what is the day? May 5th. What would be the Flipkart sales on the May 5th? First, I have to understand May 5th, it is a normal day or any special day. If any offers you are running in the website, separately you are running any offers, means obviously sales will be very high. Okay, today, yesterday, if you take yesterday in Amazon, there is no sale, nothing is there. The sales will be normal, but today some sale is going on in Amazon. Whether in Flipkart it is going on or not, I don't know, but in Amazon it is going on, right? So in the Amazon, the sale is going on for Prime members from today onwards, from non-Prime members tomorrow onwards, right? Some sale is going on. Now, some sale is going on means obviously when there is some sale, something discounts you are giving, some kind of additional discounts or instant bank discounts or no cost EMI, something special offers you are giving on this particular day, means obviously the general public will use that one. Okay. So when they use that one, automatically the sales will be very high comparatively. So first, when they ask us to predict what would be the sales on this particular day, means first we have to not only check the sales, along with that, what is that particular day, whether any offers are running or not, no offers are running. Based on that, we are going to estimate. Retrain means keeping the data inside the data set and we have to work. Is called as data retrain. Is that clear, guys? Now coming to the data wrangling. What are the data wrangling techniques we have discussed? Future transformation. What is meant by future transformation? Variable transformation only. Whatever the column is there, that column you are transforming to skew data to normal data. Next, we have worked on the second one called as future scaling. What is meant by future scaling? You are going to scale down the values to on the same scale, everything on the same scale. Next, we have seen the third one is called as future encoding. Future encoding or normal encoding, both are same. You are going to encode finally the future only now. Future encoding. What is meant by future encoding? For a particular variable, you are going to encode accordingly into number. You are going to convert to the number. If it is ordinal data, according to that. If it is a nominal data, according to that. Next, last one, fourth one is called as discretization. The fourth one is called as discretization. So these are all comes under future engineering techniques. Data cleaning and data wrangling combination is called as future engineering. Now, next one is future selection. Now, what is meant by future selection? Identifying the important futures, identifying the unimportant futures. Identifying the important futures and keeping in the data set, identifying the unimportant futures and removing from the data set. How we are going to identify? One of them is sample. I'm saying one of them as of now. Okay, detailedly we'll understand. Later we'll understand detailedly. I will take separate class for that also. As of now, just I'm saying one simple example. If the correlation is very low, what is meant by correlation? There is no relation. If there is no relation, for example, your name and whether what is the salary you will get, is there any relation? If your name is Mahesh Babu, means you'll get high salary. If your name is Suresh, means you'll get less salary. Is there anything like that? Nothing. So if there is no correlation, then you are going to remove that particular variable. Whichever the column is having the low correlation, that particular column we are going to remove. Okay. This removing the unimportant futures is called as future selection. Future selection is also called as dimension reduction. Both are same. What is meant by dimension reduction means dimensions. Dimensions means number of variables. Reducing the number of variables. Future selection or dimension reduction means finally you are trying to reduce the number of input variables. Finally, you are trying to reduce the number of input variables which are unimportant. You can't remove the important variables. If you want to remove one variable from the data set means you have to prove statistically. You can't delete as per your choice. Sir, I'm not interested in this variable, sir. Simply I'm removing. You can't say like that. The reason, what is the reason? Why you are removing that one? What is the reason behind removing? So you have to prove statistically. If you prove statistically, then you are having the option to remove that one. Right? Now, one of them statistics is correlation. As I've told you. And second one is variance. If the variance is 0, assume the variance is 0, then what is the meaning of that? What is the meaning of variance is equal to 0? What is meaning of variance is equal to 0? All the data points are the same data points. Everything is mean only. Variance means how much the data points are deviated from the mean is called as variance. If every data point is mean only, then from where the variance will be there? For example, 1, 1, 1, 1, 1, 1, 1, 1. Take in the notes example, one example. Take the column heading as X, some column heading as X. And in this column, you take 1, 1, 1, 1, 1, 1, like this you take and calculate the variance for this. What is the variance? Average also 1 only, deviation also 0. First one deviation is 0, second one deviation is 0, third one deviation is 0, fourth one deviation is 0. Everything deviations will be 0. If everything are deviations are 0 and variance is equal to 0, means this column, if this column is there also, if the column is not there also, same answer. Answer is not going to change. Okay. For example, I'm analyzing in this class male data. No females are there. Only male data is there. If you keep the male word also, no problem. If you don't keep the male also, no problem. Because you are analyzing only male now. If 2 are there, miss, then you have to get the comparison. How the males and females are different, and we do the something analysis. Only male is there, then what is the use of doing analysis? With respect to gender. With respect to gender, there is no use. No need to compare. Now in this class, how many males are there, how many females are there? That concept is not there. Only males are there. Right? If every value is same, means simply to say variance is equal to 0, that particular column we are going to remove. Means based on the variance, based on the correlation, we are removing the unimportant futures. Both of them are statistics. Based on the statistics, what is meant by if you know what is variance and what is meant by correlation, both of them we have discussed in the statistics. Right? Based on the statistics, we are going to identify which one is the important variable, which is the unimportant variable, and we are going to drop that. So here within the future selection, we are having the multiple are there. Okay, out of which the first one is called as filter methods. Don't write. Please don't write. Because advanced, this one. No need to write because you'll not understand anything now. I'm also not going to explain anything. Only headings only, right? Waste of time. Don't write. Next one is called as wrapper methods. Next one is called as embedded methods. Different methods are there to identify whether the future is important futures or not important futures. And finally, we are also having the principal component analysis. These are the 4 principal component analysis. Principal component analysis, which is nothing but PCA. 4 options we are having. In these 4 options, what we are going to do is we are going to identify which are unimportant variables and we are going to drop. So in a original data set, in the real life, we'll get with 40 to 50 columns or 100 columns. Out of those, we may have to remove some of the columns. In that case, we are going to use either filter method, wrapper method, embedded method, and PCA to drop the unimportant variables. Now, out of which the filter methods, these filter methods are based on your statistics. Based on your statistics. These embedded methods are after machine learning. Once the machine learning is completed, the machine will learn. Entire data it will learn. After learning the entire data, the machine will say that this feature is not important for me. Machine will say that answer. Machine says that it is not important for me, remove this. It will only say. For example, I want to have with respect to something data science salaries. Okay, your data science salaries are there. In data science salaries, in one of the column, I'm having with respect to intermediate percentage, 10th class percentage, BTech percentage, and experience is one of the column. Like this, I'm having multiple columns. Out of all these columns, it is giving the top priority for the experience. First top priority goes to the experience. The higher the salary, the higher the experience, the higher the salary. So experience is given the top priority. After that, it is giving the for number of projects. After that, it is taking with respect to some kind of certifications. All these are given priority. Now in the 10th class, I have got 44%. It is ignoring. Hey, I don't want your 10th class percentage. If you give to the machine will say that I don't require your percentage. So there is one project I will show you. Data science salary prediction only is there. Project is there. I will show you that one. In that, if you give the whatever the things, input data, your 10th class percent, intermediate percent, BTech percent, and this one, that one, if you write your college name, it will simply ignore your college name. It will not even consider. What is the total amount of skill set you are having? What is the amount of skill levels you are having? Level of your skills, level. Whether out of 100, 80% or 70%, that one, that is more important. Whether you are from this college or whether you are from this college, that is not important. It will not consider. Machine only will say that answer. Embedded methods means machine gives the which are unimportant and which are important. Machine will give or machine will tell which are unimportant features. Tells unimportant features. Or machine will identify. It identifies unimportant features. Machine will identify unimportant features. Okay. So this embedded methods only after the machine learning. Once we do the machine learning and after the machine learning, you'll understand. First, the machine has to learn the data and it has to understand, and then it will tell that whether it is an important or not. So first you have to complete the machine learning. And this is one of the algorithm. PCA is one of the algorithm. This is the part of ML algorithms. Okay. This is the part of ML algorithm. In that one of the algorithm. How it is going to work, this algorithm based on the covariance. This algorithm again works on the covariance. Right? One works on the correlation, filter methods works on correlation, PCA works on the covariance. That is the reason covariance and correlation is one of the most important topic in the statistics. If you remember in the two tests, whatever the tests I have kept, in the two tests I have commonly asked the question, what is the difference between covariance and correlation? In the both of them, I have asked that question. And in the interview also, in the statistics, they'll ask that question because that is one of the most important in the entire machine learning part. Correlation and covariance, both, right? So this entire, whatever the future selection is there, this we'll discuss in the later stage because this involves multiple things. Okay. If I explain this filter methods, correlation and variance, these two you will understand. Information gain, chi-square, and entropy. These words you will not understand as of now. Those words you have to understand means we have to see in the further class. So that is the reason I will explain this in the further class. Future selection techniques I will explain in the further class. Right? Done. Now let's move on to the next one. So this is with respect to called as future engineering, and where in the future engineering, data cleaning and data wrangling. Now the most important is there. The important one here I have missed. In this I have missed. What is that important one means? If a particular column is having more number of categories, for example, 30, 40 categories are there, unique categories are there, more number of categories are there. Okay. Now, in that case, what we have to do? 30 to 40 categories are there means what we have to do. So for 30 to 40 categories also, 90 categories also, 200 categories also, if first what we have to do means first step, first you have to select the column. What are the column? That column, you take that column dot value counts. First you apply this one. What is meant by value counts? Each category and their counts. For example, let us take an example like this. X category is there. Some X category is there. Just give me a minute, guys. So we are having X. Okay, X category, we are having 14. 14 values are there. X category of 14. Okay, we are having 14. Y of 14. Z of 19. Q of 20. And R with respect to 14 or 16, something. Okay, S of 20. Like this, we are having multiple categories are there, and each category, this many records are there. Now, if multiple categories are having equal number of values or almost same way, then in that case, we have to do the either one hot encoding or ordinal encoding normal. No difference in that. But some columns will have in such a way that X will have 200, Y will have 140, Z will have only 10. Only 10 records of Z will be there. More categories, more records will be of Z, X only and X and Y, with X and Y. Very less number of records will be with Z. Some cases will be there. R will have one more category will be there. Only one record will be there. That only one record will be there. Right? So most of the categories will be with respect to 200 or 140, something like this. Okay. Now, if, for example, let us assume like this. In the cinema hall, in every cinema hall or in the theater, we are having the seats. Different seats are there. For every theater, there limited number of seats are fixed for the physically handicapped people, which is very close to the near to the door. Okay, for physically handicapped people, they have to allot that one. That is the rule of government of India's rule. Now, but how many of them are following that one? Very rarely. In a particular theater, maybe 1 or 2 seats will be there. But many of the seats are general public only, normal people. Okay, 1 or 2 seats only they are keeping with separately. Some theaters, some particular like IMAX or something, they are allotting that one. They are not giving to others also. They leave the seats. If it is not filled also, no problem, but they leave the seats. They are allotted only for physically handicapped people. Okay, assume. Now they have done like this. Now, out of an entire theater of 700 seats, 698 are normal and 2 seats are like this. Now, what we have to do for this case? If this is the situation where only one category will be of 1 or 2 records. In this case, what we have to do is very simple. If it is a nominal data, then in this nominal encoding, we are also having one more called as probability encoding. The second one is called as probability encoding. Now, what is meant by probability encoding? For each category, calculate the probability. How to calculate the probability? For example, we are having 3 categories. What are the 3 categories? Means, let us take like this. X of 200, Y of 190, Z of 10. 3 of them are with respect to nominal data, not ordinal, nominal. They are nominal data. So nominal data, where for nominal data, I have to do the nominal encoding. For doing the nominal encoding, Probability encoding. How to do the probability encoding? This concept of probability encoding will be applied when we are having more number of categories, and that too inside that some of the categories are having very limited number of values are there. Only in that case this concept is applicable. Okay. Now what we are going to do is each one we are going to divide by the total. Total is nothing but 400. Now you will get the probability. This is 0.5. This is 0.45. And this will be 0.05 something. Example I'm writing. Something will be like this. Now, wherever the x is there, replace with 0.5. Wherever the y is there, replace with 4.45. Wherever the z is there, replace with 0.05. How you are going to replace means no need to write the replace option. Map function is there, right? Using the map function, you map the x values with 0.5, y values with 0.45, z value with 0.05. Now everything will be inside the 0 to 1. When ordinal data, when it is more than 1 only, then it is considered as a special cat, means higher level. If everything are 0 to 1, there will be no much difference. Okay, this is one way of encoding. Sir, how to calculate this total value divided by 400? Means are we going to do manually? No need to do manually. Just you calculate here, divide by length of df. You take length function of df. Or you can write inside normalize is equal to true. Anything of your choice. In the value counts in the bracket, you can write here normalize is equal to true, or simply calculate divide by length of df. Then automatically you'll get for each category what is the probability value and replace that probability value by using the map function. Okay, when we are having more number of categories, this is one of the option. Okay, 20, 30, multiple categories are there. That too, everything are nominal data. In that case, go with the probability encoding. Clear, guys? So this is with respect to called as data pre-processing. Now let's start with the next one called as machine learning. Now from today, we'll start with the machine learning. Okay. Now from once we see the introduction, from tomorrow onwards, every day one project. The machine learning will be for next 1 month. Next in 1 month, we are going to complete 20 projects. Every day for each algorithm, one project we are going to do. Okay. Now let's start with the first one. Introduction to machine learning. In today's class, just we'll see the introduction. What is machine learning and how it works? And what is the difference between a normal learning versus machine learning? Okay. Now, machine learning is a subfield of computer science where the computer's ability to learn without being explicitly programmed is called as machine learning. Machine learning means it automatically makes with respect to certain rules and it will only understand the things. Means what is the meaning of that example? Let us take an example. Normal general programming versus machine learning. Let us take an example. In the normal programming, for example, I have taken x is equal to 1. I have taken x is equal to 1, 2, 3, 4, 5. These are the x values. Okay. This is called as input. And I'm going to write y is equal to x plus 5. If I ask you to write a program for each and every value, add the 5. I ask you a program. Now you have written the program. The program is called as code. The code is y is equal to x plus 5. Assume this is the code. Now, based on this code, what is the answer you are going to get? Y value is equal to 6, 7, 8, 9, and 10. So this is the input and this is the output. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? And you are writing the code. What you have written the code and what the machine has given output. This is the output. Whatever it has given the outside, this is called as output. This is normal programming. Till now, what we have done. Now, for the machine, what we have to do is for machine learning, x and y, whatever we are having here, 1, 2, 3, 4, 5. The output also you only have to give. Output also you have to give. 6, 7, 8, 9, 10. You have to give the output. If you give the input and output, what it will give then? The relation between both of them. That is y is equal to x plus 5. Machine will tell this one. If you give the input and if you give the output, the machine will tell this one. Sir, how, sir? How? Generally, common question. 1, 4, 9, 16, 25. What is the next number? Huh? How? You identify the relation. There is some relation between two of them. What is the relation? First you identify. You cracked the relation between them. Between the numbers, you have cracked the relation. And based on the relation, you are predicting the next number. That is the machine learning. Simple. Whatever the data was given to the machine, it will identify the relation between them. And based on that, it will predict the equation. So first it will identify the relation. Oh, the relation is next number. Whatever the next number is there, that is the serial number squares. 1 square, 2 square, 3 square, 1 square, 2 square, 3 square, 4 square. It identified the relation. Automatically, the next number should be 6 square only. So it has predicted the 6 square. This is the answer. Sir, machine not sir. I have predicted. Yes, whatever you have done now, the same logic will be applied by the machine. Now you have applied for the small thing. Now machine will apply for the large data. Now if I give the relation, just a small example like this, x and y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What is the relation between these two? I asked the question. You told the answer as, sir, y is equal to x plus 5 because it is a simple. Now I am going to change this one to 18. Now what is the relation? Earlier answer is x plus 5. It is very simple. Now what is the relation? There is no relation. You will say that, sir, there is no relation. But still there is a relation, but not 100%. I'm not asking with 100%. Okay, not with 100%. At least almost close to the original answer, 70% or 80% something. So the machine will identify the relation between the x and y. So what is meant by machine learning means? Simply to say, machine learning identify the relation between input versus output. The machine learning is nothing but identifying the relation between input and output is called as machine learning. Nothing. Sir, can you explain with a real life example? Let us see one example of real life. Let us take a original data set, real life original data set, one of them. Okay, this is the original data set. A company is spending some amount for their advertisement on the TV. And the same company is it is spending some amount on the radio. Okay, every month they are spending some amount. Let us take the example like some Lalita jewelries, right? Everyone knows Gundu Boss is there, right? So he is going to spend the money, right? Now this person, whatever the person is there, this person is spending some money on the TV. He will come in the TV and he will say that, right? Next radio, next in the newspaper. So once he has spent this much of amount on TV, this much of amount on radio, this much of amount on newspaper, and this is the sales was happened earlier, completed. This story was completed. I'm not going to predict in the future. This is already completed one. Somewhere in the year of 2020 or 2021, somewhere he has invested the money and he has got the sales. And he has invested this money on the TV, radio, newspaper, and he has got the amount, this one, amount of sales. This many number of sales was happened. And this is the amount they have spent for advertising, and this is the sales was happened. Now the question is, after observe the entire data, now if I spend on TV 1 lakh, on TV if I spend 1 lakh, on radio if I spend 40,000, on newspaper if I spend 60,000, now what is the expected sales? This is my question. If I'm first observe this data, just observe this data. After observing the data, Just randomly guess something. You try to guess by observing the data. Whatever the data you are seeing here, just by observing, if I spend this much of amount, what would be the expected value? You are going to say, sir, around 5,000, 6,000, or whatever the number, some number you are going to guess now. The machine also will do the same. But instead of guessing, first it will identify the relation. What is the relation between them? Statistically, mathematically, it will identify. It will not identify randomly. So it will identify the relation between both of them, and it will create one equation. The equation is something like this. Y is equal to some 0.5 into TV plus 2 into radio plus 4 into newspaper. Something it has identified like this, assume. Now, 1 lakh I am going to substitute here, 40,000 I will substitute here, 60,000 I will substitute here, and I will calculate the value. Example, not the exact equation. Don't calculate. Example in a flow I have written, right? So just it will identify the relation. This Y is nothing but sales. Your sales in terms of TV, radio, and newspaper, it will identify the relation. It might be plus, it might be minus, anything. No need to have only plus only, minus also. Anything can be happen, right? But identifying the relation between the output versus input is called as machine learning. It will identify the relation. So the relation is whatever the data you have provided, it will identify based on the data. If you have given the wrong data, it will identify in a wrong way. If you give the correct data, it will identify in a correct way. If a proper data is there, the relation will be proper. So based on the data, it will identify the relation. This data is called as past data. Identifying the relation on the past data, and based on that, we are going to predict on the future data. 1 lakh, I told you right earlier, 1 lakh 60,000 and 40,000 I'm going to spend. For this, what is the expected value? This is the future data, which I'm going to spend in the tomorrow or day after tomorrow, I'm going to spend. If I spend tomorrow 1 lakh 60,000, 40,000, what would be my expected sales? Not exact answer, expected. The expected answer is, sir, 9,000. 9,000 is the expected answer. With what accuracy? 70%, 60%, 100%. Perfect answer. 100% it will give that answer only. 100% means 100%. 60 means 60. 40 means 40. Some accuracy, with accuracy. You have to tell with accuracy, sir. This is my expected answer with this much of accuracy. I'm predicting. Now, 1, 2, 3, 4, 5. This is X. This is Y. That is 6, 7, 8, 9, 10. Identify the relation between Y and X. And predict for 6, what would be the expected answer. What you are going to do? First, from this data, you are going to identify the relation is Y is equal to X plus 5. Okay. From this, we are going to identify the relation Y is equal to X plus 5. Once we identify the X plus 5, now what we are going to do? This 6 will be substituted here. And we are going to predict the answer as 11. What is the accuracy? Means 100% accuracy. 100% is going to be 11 only. 100% accuracy. For this data set, 100% accuracy we have got. If I change the data set like this, I may not get 100% accuracy. I'll predict. For 6 also, I'll predict the answer, but I can't predict with 100%. If you change the data set, this one to 81, I can predict still, but I'm not sure with 100%. With 10%, 20%, 5%, whatever it is, I'm going to predict. Based on the data, whatever the data we have given, it will identify the relation between them. Okay, that is called as machine learning. Is that clear? So machine learning is nothing but identifying the relation. Okay. So just based on the relation. So here the machine learning means just it is going to work without writing the explicitly program separately, or not going to write. Now, for example, let us take like this. X and Y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is the data set. For this data set, I want the answer as X plus 5. I know that already because this is a simple data set. I also know the answer X plus 5. But how the machine will do means from sklearn, everything. Machine learning means sklearn. From sklearn, you are going to import the algorithm, ML algorithm, one algorithm. And whatever the algorithm you have imported, you are going to save that one into a variable. Some variable is equal to whatever the ML algorithm you have imported. Now this M dot fit on X comma Y. If you write like this, what is meant by fit? I have told you, fit means calculate. It will calculate what is the relation between the X and Y. It will calculate the relation between X and Y. Simple. Only 3 lines of code. Any algorithm, 3 lines of code. Okay. First one is from sklearn, import the algorithm, and that algorithm you have to save in a variable, and variable dot fit on X and Y. Completed. So in this, what happens in the backend, how it is going to work, that we have to see. The interview will be not with respect to what is the code you are going to use, from which library you are going to import. This will not be the interview. If I click on the fit of X comma Y, what happens in the backend? That is the interview. Standard scalar, what is meant by standard scalar? Standard scaling means, sir, from sklearn.preprocessing, import standard scalar. Standard scalar is equal to SC dot fit and transform. You can't say like this. Standard scalar means converting every value to corresponding z-score, where z-score is equal to x minus mu divided by sigma. That is the answer. Okay. You are saying the coding part. I don't want the coding part. What is the meaning of that? And what is the use of that? That is important. Similarly, in the machine learning also, what is the backend of fit? What happens in that? That is important in the interview. If you explain what happens exactly in the backend of the fit, then you are very strong in the subject. If you say that, sir, ML algorithm, explain this ML algorithm from sklearn, import this one, fit on X comma Y. If you say like this, simply it will be rejected. For doing the project, this is important. For interview, that is important. So both are important. Both we have to learn. Theory we have to learn. Practical also we have to learn. So what happens exactly in the fit, we have to understand. What happens with respect to in the code also, we have to understand. Is that clear, guys? So now the next one, how the machine will learn means, whatever the data you have given, it will identify the futures. Based on the futures, it will identify that and it is going to predict the answer. So to understand this machine learning, or artificial intelligence in a simple way, dead easy way, to understand this one, just you are having with respect to go to any child, select any child of 1 year or 1.5 year, 1 to 1.5 year, in between 1 to 1.5 year child, anything. Select the child. First time for that child, you are explaining ABCD. From your perspective, ABCD is a simple one. ABCD, E, F, G, H, like this up to Z. We are going to say in just in 10 seconds only, we can complete. First time you are explaining to the particular child what is A. How you are going to explain? Simply you say A means it will accept. It will say that A, okay, this will accept. No, right? You have to show the A letter. Clearly you have to show. With A for apple, you have to show, and apple, some apple you have to bring, original apple you have to bring, or some kind of diagram you have to open, something, and you have to train them. Now it will identify that, oh, this is A letter. Okay. A letter means one triangle type shape. Okay. 3 lines will be there. Something like this. It will identify the futures. What are the futures are there? B letter means, oh, B letter means it will be like this. How the child will first time will learn that one? How the first time in the brain, what happens in that child? Exactly. Just assume. When you are teaching A letter, what happens in the exactly mindset of the child, particular child? It is trying to identify the diagram. It will not understand A letter. No English. Oh, this is English language also. They don't know. They don't know what is English language. They don't know what is meant by letter. They don't know what is meant by this one. Nothing they know. They know only one thing is called as, oh, shape is like this. If a shape is of like this, then it is called as letter A. They'll fix like that. It is called as A. If the shape is like this, it is called as C. They'll fix like this. Based on the shape only, they'll understand initially. And now the same child, okay, forget about the English. No teaching. Here also teaching. Okay, remove. Let us try with one more. Okay, go and teach to the child. Just on day one, you show one dog. Street dogs will be available, right? So in the street dog, one white color dog or brown color dog. Show one dog. And say that, hey, that is called as dog, dog, dog. Something you say like this. Child will laugh in front of you. Okay, completed. Task completed. Now, second day, you show one more dog. This time you show the white color dog. It will see you like this. Array, yesterday only, Nara, you told black color is called as dog. Today you're saying white color. First, it will see like this. At our face, it will see like that. The child will see it like that because the child will get confused because the futures of yesterday's dog and the futures of today's dog are entirely different. Next day, you show one more dog, pug dog, which will be very less height. Array, yesterday this much of height you told dog. Today you're showing this one and you are saying dog. What is this? So the child will not understand with one example. We have to train with the multiple examples. We have to show with the multiple examples and multiple futures. Okay, dog shape will be like this. Dog tails will be like this. If you explain tail, whichever is having the tail means next day cat. Hey, cat, after seeing the cat, hey, it is also dog, 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 dog. It will say like that. Hey, it is not dog, it is called as cat means. Hey, yesterday only, Nara, you told tail means dog. Again, you are saying today cat. What is this? It will say like this. Now, second day, next day, if you show the black dog, if suddenly if sees the rat also, dog, dog, dog. Because you trained the black color now. Short is there, tail is there, everything is there. So based on one or two examples, none of them is going to understand. You have to train with the multiple examples. Similarly, the machine also same. The machine, by seeing one record, it will not understand, it will not predict. If you give the more examples, it will identify the relation. Okay, from each of them, common thing, what is the common thing is there? It will identify the relation. That based on the relation, it is going to predict. The same thing happens. If you want, I'll show you the code also. And whatever I have told you just now also, I'll show you. Just give me a minute. This is, okay, this is called as convolution neural networks, which is the part of artificial intelligence. In that data set, this is the data set. Here, training means which is used to the machine to learn, which is used for training purpose, for machine to train. In this, I'm having dogs and cats. And I'm having the dog images. Total 4,000 images are there. Now I'll show the mission. I will train the mission. Hey, this is called as dog. I will not tell the answer. Answer is, this is called as dog. 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 I will not train. Now the machine will understand, from every future it will understand. If you train only one thing means, it will fix whichever is in the black color, which will see like this. It will fix like that. Next day, if you open this one, if you bring any white color or something like this, then again it will, now if you show the white color dog, it will get confused because you have trained only black color now. So how we have to train means by showing the multiple images, by giving the different images. Once you try with the multiple images, after trying this one, okay, from all the images, some images will be with respect to white color. Some of them will have the fur. Some of them may not have the fur. Some of them will have the tail. Some of them may not have the tail. Some of them, the legs will be very height. The legs height will be very high. And some of the legs will be short. Okay. So now it will get trained. Once this training is completed, now I'll train this one as cats. This one. This is cat, this is cat, this is cat, this is cat. I will train the machine. So here, though there is no cat also, still we have to train the cat. Right? They have closed the cat, right? So here it has to identify this one as a cat only. This is not cat, this is cat. It has to understand. Okay, this has to understand this is not cat, this is only cat. It has to understand means we have to train. How we are going to train? For every cat, it will identify the futures. What are the futures? Cat futures. How the cat eyes will be there. How the cat face will be there. Shape will be there. And cat ears, how it will be there. Or body shape will be there. All this called as futures. Everything is called as a future. Okay. Once training is completed. Complete training is over. Now, based on the training, I'm asking, what is this? I'll ask the machine, what is this? Predict the answer. It will say that it will check what is the probability being as a cat. How many futures of cat is matching? It will identify. Okay, these many futures of cat are matching. First, it will identify what is the probability of being as a cat. 0.1. What is the probability of being as a dog? 0.9. Which is having higher probability? Dog is having higher probability. So it will finalize as a dog. It will give the output as dog. Have you seen some Android apps where if you give your face, it will identify as your some animal name? Have you seen some kind of funny apps, something like that? At least in the videos, have you seen shorts, YouTube shorts or TikTok somewhere? Okay. So where if you show your face, it will identify yours is a dog face, or it is identifies yours as a pig face, something it will identify like that. How it is identifying means they have given in the back end some multiple images. Already they have done the training. Now, whenever you have given your face, for example, after training, I have trained with how many face, what are the things I have trained? Dogs and cats I have trained, but you have given your image. Instead of giving the cat image or dog image, you have given your image. For your image also, it will identify how many features of dog is matching, how many features of cat is matching. If your face is dog face, it will say answer as dog. If your more number of features of cat is matching, means it will say answer as cat. Just it will identify the probability in the backend probability. For the each probability, first it has to identify the futures. From the futures, it will identify the probability. In that way, it is going to work. Got the point now? What is machine learning? Machine means it learns the futures. Similarly, the child will learn internally how the child will learn. Similarly, the machine also will learn in the same way. If you train the child with one example, child will not understand it. For example, if you go and show the child apple, red color, pure red color, take the apple and say that it is called as apple. Next day, you bring that green apple and you show this is also called as apple. Just observe the reaction. If you are having the child at home, try. So that artificial intelligence will be dead easy for you. Give a try. First day you give with the only red apple and next day you try with the green apple and see the reactions. What is the reaction? First day you say this is called as apple. Second day also you say this is apple. Okay. So internally what happens inside the brain of the particular person means it will identify the futures. Oh, this is red color. This shape is like this. So then only it is called as apple. They'll fix like that. So what we have to do means we should not fix with one example. We have to train with multiple examples. We have to bring with dark color red apples, light red apples, with respect to upside, whatever the things are there, that one we have to bring, which are having the some dirt over the apple, whatever the dirt is there, that one also we have to bring. Like this, if you bring the multiple apples and if you train, then properly it will learn. Then proper learning will be there. Is that clear, guys? So finally, the machine will extract the futures and based on the futures, it will predict the answers. Done? So that is with respect to, sir, ML and AI stuff means, to my knowledge, it is the dead easiest subject for me, from my perspective. When compared to my Python or when compared to anything, I feel machine learning is dead easy. Because here logic only will be there. There, no logic, only coding. We have to sit and write code. From morning to evening, we have to write the code only. No need of brain. But here, completely only brain. Logic. What is the logic behind that? Right? Is that clear, guys? Now, within the machine learning, we are having different techniques, out of which the first one is called as a regression. Now, what is meant by regression means you are predicting the continuous variable. If the output variable is continuous, then it is called as a regression. If the variable is not continuous, then it is called as classification. So here, before writing this one, write in the notes. First, data, heading as data. Data is of two types. One is structured. Second one is unstructured. We are not going to work on the semi-structured data, only directly unstructured data. Okay, data, structured or unstructured data. Structured data, unstructured data. Now within the structured data means which is having a proper structure, means which is having a proper format, like tabular format is called as structured data. Which is not having any proper format is considered as unstructured data. No format will be there. Like example, images, videos. For videos, there is no proper format. You have to start here, you have to end here. There is no proper format. There will be nothing. And the video will be, some people will record in a slow motion, some people will record in a normal videos, then some people will take some kind of micro shots as per their choice, right? So images, videos, text, audios, all this comes under unstructured data. There is no proper format for them, right? For analyzing the unstructured data, we have to use AI. Analyzing the unstructured data is AI. Analyzing the structured data is ML. ML and AI means ML is used for structured data, for unstructured data, AI. Right? So ML. Now within the structured data, now coming to the structured data. Okay. So for structured data analysis, all the structured data analysis, we are going to use ML. Now within the structured data, now heading is structured data. Exclusively structured data. Now within the structured data, we are having, first one is called as cross-sectional data. Second one is called as time series data. The first one is called as cross-sectional data. The second one is called as time series data. Now, what is meant by cross-sectional? Which data is not dependent on time? That data is called as cross-sectional. Earlier, whatever the example I have shown you, the TV, radio, newspaper, and says, some example I have shown you, some data set. In that data set, is there any time column? Is there any time column, date or month or year or something is there? Nothing is there. So then it is called as cross-sectional data. If time related one variable is there also, then it is called as time series data. Either month, either it can be day, it can be time, hours, minutes, or month or year. Anything comes under time. Year, month, date, time, within the time again hours, minutes, everything. All of them comes under time. So for time series data, we have to analyze separately, time series analysis. Okay, where we have to predict the stock market for a particular share. Okay, Infosys share price we want to predict. Then we are going to apply the time series analysis. Okay, and there is no dependency on time. Then we are going to work on the cross-sectional data. For example, I want to predict what would be the traffic at Amirpet. Automatically, as per the time, it changes. At night, 2 o'clock, that Amirpet, it is completely empty. You can even go at 100 speed also, no problem. But at 7 o'clock, 7 or 7:30, the traffic will be very high. We can't even go at 30 speed also. Right? Example. So just we are predicting the number of what is the traffic at different time. So then it is considered as time series data. Right? Now coming to the cross-sectional data. Within the cross-sectional, we are having two again. That is continuous and discrete. Already you know. One is continuous and one is discrete. Whereas a discrete, within the discrete, again two are there. One is discrete count and discrete categorical. Again, discrete categorical, again two are there. One is nominal and second one is ordinal. So already we have done in the statistics. In the statistics, already I have explained what are the different cross-sectional data we are having. That is continuous and discrete. Now here, coming to this one, now here I'm having one is called as labeled data. Labeled data. Second one is unlabeled data. Unlabeled data. This is most important. Labeled data and unlabeled data. Now heading is labeled data. Write in the notes labeled data. Now what is meant by labeled data? If there is a output variable, if there is a output variable in your data set, if there is a output variable, then it is called as labeled data set. Okay, let me write here in the notepad. Okay, label data. Heading is label data. Label data. What is meant by label data? Label data means if in your data set, if you are having in your data set, if output variable, if output variable is available, then it is called as label data. In your data set, if output variable is not available, variable means column, output column is not available means variable means nothing but column or future. Variable, column or future, everything are same. If output variable or output column is available, then it is called as label data. If the output variable only not there, there is no output variable, then it is called as unlabeled data. In your data set, if no output variable, then if no output variable is available, or simply if output variable is not available, generally don't write sentence along with me. What I'm going to write, I also don't know. I will edit like that. It is better once I write, after that you write. Okay, generally I will edit. I will not frame the sentence as it is. Okay. So label data means in your data set, if the output variable is available means it is called as label data. In your data set, if output variable is not available, if it is not available, then it is called as unlabeled data. Okay. For label data set, we are going to apply, we have to apply supervised machine learning, techniques. We have to apply supervised machine learning techniques. For unlabeled data, we have to apply unsupervised techniques. That's it. Only unsupervised machine learning techniques. For labeled data, we have to apply supervised machine learning techniques. For unlabeled data, we have to apply unsupervised machine learning techniques. So machine learning is again divided into two parts. One is supervised and one is unsupervised. Where the machine learning is of two types. One is supervised machine learning and second one is called as unsupervised machine learning. What is meant by supervised machine learning means you are applying the machine learning on the labeled data, then it is called as supervised machine learning. If you are applying the machine learning technique on the unlabeled data set, then it is called as unsupervised machine learning. Is that clear? Now, what comes under supervised machine learning techniques? What are the supervised machine learning techniques means? Regression and classification. These are the only two. One is regression and one is classification. These are the only two. Supervised machine learning techniques are two. One is regression and second one is classification. These both comes under supervised machine learning techniques. Right? Whereas unsupervised machine learning techniques, apart remaining regression and classification, everything is unsupervised only. So what are those techniques that we'll discuss in the tomorrow's class? List of machine learning techniques and what are everything we'll see the introduction in the tomorrow's class with all the techniques one by one. And what are the different types of techniques are available, and in which case, which one we have to apply for which type of data, which one we have to do. All these things we'll see one by one in the tomorrow's class. Is that clear, guys? So that is the end of the session for today. And if you are having any questions, you can ask. Okay, don't miss tomorrow's class. That is the base part of the machine learning. And from here, everyday class is highly important. Till now, okay, but now very highly important. For that highly important, you have to understand means previous one is more important. If you understand the previous one, fundamentals are strong means from Monday, you will feel dead easy. Write this point. If you are very good at till now, whatever we have completed, if you are very good, from Monday, nothing will be there. Simple. Sir, machine learning means this much only. Yeah. For this, we have spent almost 2 months. You'll feel like this. After understanding, without understanding, if you come means